Okay, AP Environmental, this is Unit 5, Topic 5.10. It is on urbanization and water use. All right, we've talked a little bit about water use, just kind of touched on it a little bit last week when we talked about irrigation. And we're going to kind of expand upon that a little bit today, but we're going to kind of reference it and kind of tie it into this topic of urbanization. So let's first talk about what urbanization is. Urbanization is basically the accumulation of people, in large areas that form cities. Urban, refers to, like cities, like Chicago, for example, is an urban area. Northwest Indiana would not necessarily be an urban area. It would be more of what we call a suburban area. So these areas that are like on the outskirts of a city, where a lot of people live, and a lot of people actually rely on the urban area that live in the suburban area. But again, those are suburbs, those areas that are kind of on the outskirts of big cities. So there's a term here called, I actually want to go back to this picture real quick. One of the things you'll notice in this is all these little dots in orange and yellow, and those brightly colored dots basically represent urban areas or even maybe suburban areas around the country. And you will notice that, for example, the Mississippi River, which would kind of cut right down the middle here, right? The Mississippi River to the east, there seems to be a lot more coloration, right? There seems to be a lot more urbanization compared to the western part of the United States, and that's true. Unless you live in, let's say, Los Angeles or Southern California, or like you'll see, for example, this is Las Vegas right here. Phoenix, right in here. Maybe Seattle, Washington up in here. There really, is a lot of dark areas out here, and that's because those areas are not urbanized and not a lot of suburban areas either. So this term here, urban sprawl. If you kind of look here, this is a map of Philadelphia and how Philadelphia has kind of changed over the years. Not just necessarily as far as how many people, but kind of where those people are living. And you'll notice, like back in the 1930s, for example, like most of the people like lived in this kind of central area of Philadelphia, kind of highly like densely populated. This would be like the urban area. But you'll notice that 40 years later, how the population has not only grown but it's expanded outwards. Same thing over here. It's just kind of grown and expanded outwards. So we call that urban sprawl. So like when more people tend to occupy an area, they tend to want to like move away from each other and spread out a little bit, and that's how we end up getting our suburbs, that end up being occupied and populated. So urban sprawl, and because people are moving outwards towards more rural areas, and really think about like Northwest Indiana. For a long time was farmland. And now you don't really think of Northwest Indiana really as being farmland. It's more of a suburban area. But along with urban sprawl, comes a lot of environmental issues. One of them is pollution. You can imagine that if you have people moving from the cities outwards towards more rural areas, then more pollution is going to follow them, either air or water. Fragmentation of habitats. You get a lot of habitat disruption, via roads or pavement or housing developments or whatever it is. You're going to fragment the natural habitats of those areas. The other big issue that we have, this is one that we're going to kind of focus on today and tomorrow, is water use. Because you have more people and they're kind of moving outwards. Water is going to become an issue as far as how people get water. And there's some problems that kind of underlie that. All right, so let's talk a little bit about water issues today. And we're going to kind of focus on groundwater. Groundwater is exactly what it says it is. It's water that's under the surface. We talked last week about only 3% of the water on this planet is fresh, and I want to say like 25% of it or 22% of it is under the ground. So if we're going to get access to fresh water, we have to find this water under the surface. So we have a term here called an aquifer. An aquifer is just a source of groundwater, that we can use for whatever reasons we want, usually for drinking water, or just using it in our homes for a variety of reasons. Now we have two different types of aquifers. One's called an unconfined aquifer, the other one is called a confined aquifer. And I want to make sure that you guys understand the differences between the two. So if you look at this picture here, okay, right here we have the land, up here the surface, and then below the surface, you actually have two different sources of groundwater. All right, the one closest to the surface is what we call an unconfined aquifer. And then the one below that is what we call a confined aquifer. And really, what kind of separates the two of them is you'll notice that there's this kind of thick layer of rock. Okay, this is impermeable rock. Water can't permeate through that, but it's kind of sandwiched sort of in between both sources of groundwater. Now, I'm not going to say that everywhere that we live on this planet are there unconfined and confined aquifers, but in this picture, we just happen to see both of them here. Okay, so let's first talk about an unconfined aquifer. Okay, this one is the closest to the surface. Now, you'll notice that there's kind of this little spring here. It's like a little freshwater stream. Those aren't always there. This one happens to be. But you'll notice this is kind of an area where at the surface, we can access the water from that unconfined aquifer. So if this guy here wants to walk out into his backyard and obtain water from this spring, he's actually obtaining it from that unconfined aquifer because that spring is a part of the unconfined aquifer. But those aren't always there. Sometimes they are, sometimes they aren't. Now, the other way that he can access the water is through a well. Basically, you can just drill down and you can just pump the water out, and you can use that water for a variety of purposes in your home. So it's fairly easy to access that water from an unconfined aquifer. But you can imagine that as soon as you start pumping it out, I mean, think of this thing as like a straw, and you start sucking water out of it, the water level is going to lower. We call that the water table, which is the kind of the uppermost region of the groundwater. So as soon as the water starts pumping out, you can imagine that the water table is going to lower. And if that water table lowers enough, think about what might happen to this spring. That spring water might lower as well, right? So, an unconfined aquifer, again, it's just underneath the soil. Now, anytime it rains or there's any type of precipitation, that could fill this aquifer. Let's say you have a heavy rainfall, and the water can do one of two things. It can either just go right into this spring, right, and that would help fill the aquifer, or the water can just percolate through the soil, and it could fill the aquifer. All right, so that water from the atmosphere that comes down, that's how this aquifer would get recharged or refilled with water. Now, one problem with an unconfined aquifer is because it's so close to the surface, any chemicals that might be in the soil could eventually end up in this aquifer. I mean, imagine, this homeowner here, I don't know, sprays pesticides or fertilizers on his lawn, or whatever, any type of chemical. Those chemicals, can eventually make their way into this spring, or they can, again, as the water percolates through the soil, it can carry any of those chemicals with it. You got to remember, water is the universal solvent, so anything can pretty much dissolve in water. So if there's a bunch of chemicals on the surface and it rains and that rainwater moves through the soil, the chemicals are going to move along. So a lot of water that's in an unconfined aquifer, it has to be tested a lot, and it has to be treated, before it can actually be used for human consumption. That is, if there's anything bad in the water. All right, so keeping this thing free of contaminants is a really important thing. All right, so a couple things about unconfined aquifers again. Here's a term here called groundwater recharge. Recharge is just the input process for how water fills an aquifer. And if it's an unconfined aquifer, the way that that would happen is basically through rainfall. That's how that would occur. The water table is the surface of the groundwater, and that water table could sometimes go up, sometimes go down, depending on the different activities. That's either recharging it or pulling water from it. Again, unconfined aquifers recharge when the water travels through the soil. Um, the water that's in an unconfined aquifer, we typically call that young water because it's water that was recently in the atmosphere and now it's kind of made its way into the aquifer. So that's younger water. It hasn't been in there for very long. Again, we talked about contamination. This is a real big issue, facing unconfined aquifers. And then we can always pump the water out with a well, if we need to. Again, that's really not that difficult of a process. All right, now a confined aquifer is, again, a little bit different. You'll notice that, again, from that picture, in a confined aquifer, there's that layer of rock that kind of stops anything from entering it. So if I go back to this picture, show you here, here's the confined aquifer. When it rains, the water that moves through the soil can't get past this rock. So that's not how a confined aquifer would be recharged. The only way that the confined aquifer can be recharged is if the water enters what we call a recharge area. And usually those areas are quite small. So, I mean, you can probably imagine that these confined aquifers are much slower to fill with water than, say, an unconfined aquifer would be. There's usually a lot less water contamination in a confined aquifer, mainly because that recharge area up here it's probably less prone to any contamination up here, but maybe not. I mean, there still could be some things that get into here, but usually this is much less contaminated. If we're going to drill into a confined aquifer, it's a much more difficult process because you're drilling through rock, right? We drill through that rock. That's a little bit more problematic. So usually once they get past that, the water that's in that confined aquifer is usually under a lot of pressure. So that water will just free flow to the surface and just keep moving. All right. So, these artesian wells are much different from, let's say, like a regular well. All right. So again, a confined aquifer, what I just talked about, they're capped with impermeable rock or clay. The water can't percolate through the soil, so there needs to be a recharge area, which means that they're really slow to recharge. Again, the water is usually much older that's in a confined aquifer compared to an unconfined aquifer. It's usually less contaminated. Then we have these wells again called artesian wells that constantly free flow water up to the surface. So there's a difference. There's some differences. All right, this is a map of a whole bunch of different aquifers that we can find in the United States. You'll notice up here in the Great Lakes area, there's several different aquifers up here. Lots of groundwater. Most of that groundwater, actually comes from Lake Michigan or comes from the Great Lakes. But again, there's lots of different sources of groundwater here. The one I want to focus on is right here in the middle, this kind of area in light blue. This was mentioned last week in one of the videos that we watched. It's called the Ogallala Aquifer. It is the largest source of groundwater that we have in the United States. It's about 175,000 square miles of groundwater. And most of this is confined, so it's like underneath rock. We're mainly using this water for irrigation purposes, but we're also using it for some suburban and urban use of water as well. Um, but the problem with this is, again, we are draining the water much faster than the water can recharge itself. So, there's a real fear that, possibly in the next 25, 30 years, that we might drain all of the water out of this and have nothing left really to use. But again, you got to think about where this aquifer is, right? There's a lot of farmland around here that relies on the water that's in that aquifer. So the people that live there and how they're using that water, they probably need to rethink about how that water is being used and how much of it they take out of it every single day to allow that water to recharge itself. Here we have an example of a situation that could occur if water is pumped out of an aquifer too quickly. So here we have, let's say, three homeowners. And we have this guy on the left here, got this guy over here on the right, and then we have this guy in the middle, who's obviously a farmer. And on each person's property, they have their own wells that are tapped into the same aquifer, and they can pull that water up and use it for whatever they want to, right? I mean, this water is kind of a commons. They can use it for whatever they need to. But this farmer is obviously going to use the water for some different purposes than, let's say, his neighbors are, right? He's going to use this water, probably to irrigate his crops or to feed his animals or whatever he's going to do. So he's going to be pumping water out at a much faster rate than what his neighbors are. So this is kind of what it looks like before he starts pumping out all of his water. Well, let's take a look at what it looks like afterwards. Because if he's going to be pumping water out at a much faster rate than his neighbors, it creates something called a cone of depression. A cone of depression is basically when the water table, kind of forms this, I guess, cone, they call it, cone of depression. And you'll notice where the water table is much lower here compared to where his neighbor's water table is. But you also have to remember that his well is a lot deeper than his neighbor's wells are. So if you'll notice, like this guy over here, for example, his well no longer reaches the water table. And the same thing with the person over here. His well no longer reaches the water table. So this guy can still comfortably take water out, but his neighbors cannot. So, if I was his neighbors, I probably wouldn't be very happy with the rate at which, this guy is pumping water out, because it creates this cone of depression in the water table. And the only way that is going to go up is if this guy stops pulling this water out. He has to slow that down, and it has to recharge itself. So hopefully there's a rainfall that can help recharge this water table. If not, these wells are going to remain dry. Okay, so that's a major issue. Another problem with wells is something called saltwater intrusion. And this typically happens near the coast, like near the oceans, like where there's salt water. So, for example, let's say you got like a neighborhood or something, you have some houses, and they have a well, and that well is tapped into a freshwater source of groundwater. But these people are near the ocean, right? So ocean water, which is salty, and then we have fresh water, which is not salty. Those two types of water have different densities, they have different properties. So typically they will kind of just separate each other just naturally. And naturally, the fresh water and the salt water just kind of remain separate from each other. But let's say, what would happen if they overdrew this well? If they were to, suck up water out of this well, too fast. If that happens, then this picture on the right, when they overdraw it, it kind of forces the salt water to move in. And when they get salt water up that pump, that's not good. All right, that means that they've pumped too much fresh water. There's too much salt water going in. They can't use salt water to drink, so that is not a good thing at all to have happen. The other way that this could happen is if the sea level rises, like, and this is happening because of climate change, like the average level of the oceans is going up, maybe like a centimeter a year, or whatever it's going up. But that rise in sea level is pushing that fresh water inland more. And if this, I mean, this well is permanent. I mean, it's not moving anywhere. So if that salt water moves in, it can go up the well as well. So, that's not a good thing. These wells are designed to pump fresh water. They're not designed to pump up salt water. So, I mean, I guess what would happen if this were to occur? Well, I suppose they can move the well. I mean, they can maybe cap this well and then drill another one. That would probably be really expensive to do that. Or these people can just move, I guess, go somewhere else. That's an issue. So saltwater intrusion, make sure we know what it is and two different ways that it can happen. All right, last thing today, urban areas and the water cycle. So, a lot of times what happens when you get people that move into a rural area, or they move into an area that normally isn't occupied by people. Like, for example, this picture here on the left, right? This is an area that's kind of a natural area, forested area. People aren't really living there. It's definitely not an urban area. It's not a suburban area. And then this picture on the right would kind of show you what would happen if, like, somebody built a house on that land. I mean, just something very simple, right? So this would be more of an urban or suburban, I guess, picture compared to what we have on the left. Now, there's a few issues that occur anytime we have development on a piece of land. One of them is the creation of impermeable surfaces, things like roads, pavement, parking lots, whatever these things are. These are things that are impermeable. So if water lands on them, the water can't get through and get into the soil. So you can imagine that that's going to lessen the amount of groundwater. So that's not a good thing. So our aquifers will be much slower to charge up. Less trees, right? We have less trees over here in our picture to the right. And we also have more pavement, right? So that'll mean more surface runoff. Because again, think about what trees do. Trees can absorb a lot of water, right? And the pavement is going to allow the water not to get into the soil. So if you have less trees and you have more pavement, that's going to mean more surface runoff. So that's why this arrow here is much larger than this arrow is over here. All right, that's all because there's more surface runoff here compared to what there is over here. All right, finally, less trees equals less transpiration. Remember, transpiration is when trees give off water and the water goes up into the atmosphere. Well, if you cut down a lot of those trees, you don't have that transpiration that occurs. So this actually affects climate change. If we're going to remove all these trees and build housing developments and build shopping malls and baseball parks and grocery stores, we're actually affecting the climate when we do that. All right, so these urban areas, these developed areas, do impact the water cycle, and that does have an impact on the climate. All right, guys, we're going to stop here today. We'll continue with this tomorrow with kind of part two. But just make sure you check your Buzz agenda today. There is a couple of assignments in Buzz. All right, have a good day.